My name is Matti Seikkula. I'm CIO in Geospatial. We are an integration company specializing in geospatial integration pretty much across the board. What I will be talking about today is we do believe that geospatial, everybody should have that in their organization. And what I'm trying to do, what we're trying to do is try to prove you why you cannot live without it anymore. This will be sort of be done in three parts. So I'm going to start and go through a couple of examples on how and what you do nowadays, where the world is going to, what people are doing with geospatial now. And then I'm going to hand it over to Nissa Karanna-Veera from ESR, who's going to tell you a little bit about what they do. And then we're going to end up with something slightly different. So I'm not going to tell you anything about that yet, but you'll see in the end. That clear is pretty interesting. Anyways, okay, so two of us, as we said. This is going to be really graphically intense, though. There are some bits where I just tell you not to kind of switch off and don't try to follow the slides too closely, but I'll tell you when we're there. So start with some myths. So the idea here is that there are a couple of myths that we picked up about geospatial that we're trying to break. So first one is the obvious one, which is what it's all about, that geospatial is not relevant to my business. I'm a bit of a geek. I like all this kind of geeky Star Trek type of stuff. So we've been doing geospatial for years. I mean, some of us long time, and we've sort of known that there's something special. And IT is now ready. It's easy enough now to start. Like Ed's presentation yesterday, geospatial there's nothing special about it. It can be part of your enterprise IT like everything else is. So the great secret there is that geospatial is everywhere. So consider this nice little picture of Wellington. Nice, as it is always in Wellington like this. This is sort of how you see the world. But what we actually see is this. There's geospatial practically everywhere. Some aspect of business sector that is using geospatial somewhere within our world. So maybe it's sort of the time that people start thinking about all these opportunities and how to actually tap into this. So this is a slide that was provided to us courtesy of Eagle, our partners. It was done by one of the Esri guys who came over from US, and as you do, nothing else to do in the evenings, this is sort of how you spend your time. So how are we going to do this? This is sort of 10 business sectors across the board, and then all of these have about 60 subsectors underneath. So that should sort of cover pretty much anything you can think of. And what we're going to do is I'm not going to actually go through and stop on any of these maps. So there's about 120 maps here, right? So I'm just going to skip through them quickly. The idea here is not to concentrate to anything specific. It's more about proving you that there is a solution across the board for pretty much anything you can think of. And you will see your sector flipping by at some stage, and there you go. So starting with the traditional ones like banking, facilities management, insurance, media, press, retail, real estate, defense has all sorts of different things. So these are all done with geospatial information systems, showing and proving and finding out information about a specific system and just looking at it in the geographical sense. So no matter where you go to, what you look at, whether it's health, whether it's government, it's mapping and charting is the obvious one. So these guys are doing all sorts of interesting things. Natural resources like mining, which is quite important here in New Zealand as well. Climate, how that changes, emergency management, etc. So like I said, I'm not going to stop on any of these. So just skipping through them one by one, and eventually we are there. There you go. 120 maps in less than 2 minutes. But the idea, like I said, was that this, across the board, geospatial is everywhere. So I would say that that's a fact, not a myth. Second bit is about maturity. So, like I said, geospatial has been along for a long time. It's been used a lot in the desktop kind of environments. But as eSpatial, for example, for 12 years now, we've been doing enterprise IT level solutions that just open that one up. So I'll do it as a history, as a teacher kind of lesson. Here's a little application, Windows mobile application, and I'll just show you a couple of things what it looked like. Allowed you to do searching, allowed you to do satellite imagery, allowed you to look at regions, you know. You can go really close in the map. It was really fast. So essentially this was enabling the company Geospatial via mobile device. There was no difference from what you could actually see with it. All the maps came back within 2 seconds, so it was actually pretty fast. Could deal with resolutions down to 10 centimeters, satellite imagery, all that kind of stuff. Customer data was refreshed every 30 seconds. Visits for like nice visits to do sort of a field level capture and all that kind of stuff. GPS used to locate yourself, all that kind of stuff. Users loved it. So what actually went wrong with this? Well, when was that released? This one we did 8 years ago. So that Windows Mobile was Windows Mobile 2002. What was its biggest downfall? Well, you can guess that. Kind of works very nice when you're in urban areas. You go anywhere a little bit further away. No connectivity. Too bad. The whole thing cost to build about 80K. So it wasn't an expensive project or anything like that. If you did that today, so what would be its biggest problem today? Any guesses? Nothing's changed. Connectivity. So New Zealand is still backwards on that. How we would mitigate that is offline and synchronization. So systems now actually allow you to have an offline. You can download the data into your devices and do it that way. If we were to do that, we could probably do this with 50K. Biggest reason is that there's actually products available. You can buy out of the box products, just configure it. Actually, some of the organizations who are using mapping systems probably already have it. They just haven't tapped into it. 8 years ago, yep, it was immature. Definitely not today. Here's another one. This one was actually used for quite a while. It was used for retail planning. It was quite successfully used for finding out places to put retail systems. It was used by Oceanic Retail Company, about 10 countries. Main decision tool for planning and forecasting. It was kind of the first time ever you have business intelligence and location intelligence solutions together, shown and supporting each other. Full location intelligence, no need for internal specialists, reasonably easy to use. Successful business and right choices. Even the sales team knew how to use that. So what went wrong there? Well, start again the same way. When was this out? This was done 10 years ago. So again, quite a long time ago. Problem with it was that we have it centralized in New Zealand, and the New Zealand bandwidth to the other countries wasn't the best. So absolutely brilliantly fast in New Zealand, but Aussies hated it. What did it cost to develop? It was about 150,000 at the time. Same doing that today. The problem won't be the bandwidth anymore. Things are done differently now. You download a lot less across the board. You can minimize it, compress it. The problem is that now we have so much data that all of these we have systems with terabytes of data in there, and it's sort of growing rapidly. But there's a way to mitigate the mapping data, and we use tile cases. So we can case it all for you, and only like 5% of your data is painted on top of it. So it kind of works quite well that way. Cost for that now today would be around 100K. So it's not actually that hard to do. That was too early, absolutely, but they did use it for many, many years. Again, why would you not do this today? Yeah, so old stuff. You need to start from somewhere. That's a 1995 map. They look kind of like this. I think this is one of the hurricanes ravaging the US coastline. 1995 is when the pie charts came into the Excel spreadsheets. 96, they were already using them in mapping. So you had maps out there which were actually tying the pie charts together pretty much straight away. So you'd sort of think that they were pretty reactive there. No, they were actually proactive. This is a French map that was produced in 1890, so they had pie charts already then. Probably the knights there going on. Okay. Anyways, pie is an old trick. We kind of done that and tied it together years and years ago. So all of the mapping systems there's a whole lot of experience on geospatial specialists on how to do different kinds of things that you haven't even seen. So point to this is that geospatial is mature, has been for a long, long time now. So maybe it's something you need to start looking into. So bust that. It's definitely mature. Geospatial integration. Again, it's not special. That's I suppose the point. So Microsoft definitely believes on this geospatial integration. The support is already there for SQL Server Spatial. You know, SSRS is supporting that now. SSIS, by supporting the standards like well-known text, we can actually use that to push the geometries through. SSAS is something that's happening there in the background, not probably as fast as the others yet, but definitely happening. Bing Maps has been around now for a while. And then you have all these development tools which are just perfect for us. Silverlight, Visual Studio, the whole .NET framework, Moz. We're using Moz now a lot to actually marry the maps and the charts together. And even tying it like address validation and things like that into Microsoft CRM. So we've done that for a couple of customers in New Zealand. Office on actually starting to push the mapping information there. We have a solution for 2 of our customers where the whole mapping interface gets pushed to Microsoft Excel and you can actually use it there with the spreadsheets to look at your data yourself. And Microsoft has alliances with Esri Mapit, Esri Bing, so you can actually push the imagery into the Bing imagery to the Esri systems and to map info as well. Couple of customers specifically for Microsoft environments of ours. So there's a lot of other integrators as well there. So pretty much most of the government organizations, for example, use it. Commercially starting to use it more. So using SQL Server Spatial, there's a list of couple. Using addressing in the SQL Server database, there's a couple for you. Bing, you know, that's sort of starting to happen more. And then you have others who use Visual Studio.net and, you know, tie it together. They might be using a different database or they might be using some different things, but they can actually tie it all together. So some of these local examples, and yes, I know it's a Google map. Don't look at that. So this is our product, an addressing product that lets you do predictive typing into the address. It's a smart one, and it basically shows you where it is. Or you can do a corner of which works for kind of rural areas where you don't have as good addressing. And then you can bring the data into Bing as well. So in this particular case, just shows you a little address point on top of the 3D map there. New Zealand Transport Agency has been a customer of ours for years. So what I've done is in this is I've actually, a lot of these examples, I've dragged them from the net. So these are all kind of images that are available in the internet, rather than tapping into any specific secrets. Because that's the only problem with geospatial is that a lot of organizations use it for give them competitive edge for things. So there are a lot of things that you can't show. Like, for example, we can't show anything that police does, and they have 5 of our applications in there, so which is a shame. So they have interfaces for searching, they have interfaces for sort of group level, they have hundreds and hundreds of layers of data that they group into layer controls. You have MAF has had their climate change forest allocation schemes going on for a long time, where you can actually draw polygons in the maps and say what your forests are, and then edit them and view it and do it as a summary report. TPK is showing their information on the Mari land in the web, and that's actually a public website. You can go have a play. It's Bing solution. Nice when you put the 3D imagery in and sort of overlay it with other layers, and it kind of gives you quite interesting look and feel. Ministry of Fisheries has been doing this for years, so we had originally helped them to build their first systems. One of our architects has been involved with them on defining the .NET solutions, so they have all this information about the fish species, so this is also a public system that is available for you to view. Express Couriers, we did a demonstration on this last year, so they've been using their system quite happily for a while now, managing their courier routes. Farmers Mutual Group is a new customer of ours, so we've done some work on there, starting to show you what you can do with insurance on those areas. And New Zealand Statistics is not a customer of ours, except for the fact that we were advising them when they were building the system. So this is a pure Bing solution where you can actually go and look at the census data in context with the Bing maps. And the last one is brand new of ours. So this is a Silverlight technology, ASP.NET 4 solution for Historic Places Trust, where the mapping is actually integrated into their system. So it's not a map-centric one, but actually map is just one of the tabs where you can view the information about the historic places and define whether if you want to do a project somewhere there, whether that's going to be affected by it. Allows you to do redlining, allows you to draw polygons around and save them in the database and all that kind of neat stuff that Silverlight lets you do easily. So absolutely very easy to integrate now. Every year it becomes easier and easier. And most of it is via spatial services and these interfaces that we have in place. So the fourth myth is that geospatial is a niche market. Now, if you asked me this year ago, I would say yes, it is. But we've done a lot of digging on that, and things have actually changed. So I started looking into what's the definition of a niche market. So narrow range across industries. Well, we kind of proved that already with the first fact there, and it's that it's not really narrow range at all. It's all over the business sectors. Specialist and hard to integrate. Well, we actually can integrate it with everything, so that's not true either. So I have two left, that there aren't many vendors supporting it, and then that it's financially small business. So if you look at those, so times have changed in the last year. So it used to be just traditional vendors who did this. So like our friends in Esri and MapInfos and Integraphs, etc. And then integrators like ourselves and Eagle, organizations merged. Open source introduced a whole bunch of new players into this market. Google introduced a whole bunch of mashups and people starting to use that. And then .NET and Bing and Codeplex is a lot more again. OpenStreetMaps, open layers. So we actually have a huge number of organizations doing geospatial now. And there's more and more coming all the time. So I think that's a fact that there's actually several levels of support for geospatial now. So that kind of takes care of that. Small business. This is a Lean statement of intent. That's available in the net as well. Geospatial impact for New Zealand GDP, which is 133 billion, is 1.2 billion. So, and with wider better use within business, you could get another 500 million on that. So, yeah, okay, 1 to 1.5%. Doesn't sound, actually sounds like a niche market to me. But there's the first issue with that is that that's more like the traditional systems that actually talks about. That doesn't take into account the cloud, like a long tail systems like crowdsourcing, address value, anything without a map, for example, that won't be included. More importantly, I tried to actually find some examples on how much of the New Zealand IT covers, the GDP. There isn't any information available for that. But what you can find is that there's been some studies in EU countries done that typically IT is 5% of your GDP. So 5% of GDP and geospatial is 1% of GDP. So I think, the numbers kind of speak for themselves. Of course, the same applies for the IT. That would be traditional IT and not all the sort of fringe areas that are covered. But I think what you can see from there is that the geospatial sector of IT is actually reasonably large and it's growing rapidly. So definitely is something that you need to think about, which kind of caters for the fact number 6. So, okay, so we sort of busted those myths. I hope I did. But we're sort of missing one sector. It's the social networking kind of stuff that's happening everywhere now. So I thought that I'd just go through some of the, I suppose, more not so traditional things that are happening right now. So you start to get a bit of a picture of what's going on there. So Facebook actually now has several geospatial mapping interfaces in there that people use and communicate together. So does Twitter. So you can actually see where people tweet, not just get a little text message on your device. Photo bucket lets you kind of tie your photos into the system. So does Flickr, so you can actually see geographically where they come from. And you saw some of that on the keynote, and that's sort of old news, I suppose. And Picasa does the same one. So all of this is a geographical information, Sea-Dragon as well. So where it starts getting interesting is then all these other things that are happening. So augmented reality is a big thing right now. If you look into the Gartner hype cycle, that's really happening this year. It's a real success story. Everybody's building around that. So, I don't know if you're familiar with that, but the idea is that you view the world through your mobile device and you can get all sorts of additional information about the sites that you visit, which is quite neat. So how it works is your camera recognizes a place by the image. Compass and GPS are used to figure out location, direction of the view. Then you put an internet to figure out information about it, and then you mobile overlays all that information on. So you get this view. You have actually a version for fishermen. There's a version for hunters. Of course, doesn't work in New Zealand because you don't have any coverage, but you get the picture. And you have a version for iPhone. So then you have this tube augmented reality apps as well, which let you do that kind of information. And then there are sort of other weird things. So this one I like. This is a GPS minicap. It's quite successful in London. So basically looks like that. So consider this. Let's say you were drunk and disorderly somewhere and just want to go home. Surely happens to everybody, not just me. So you find it really hard to talk. So even harder for us foreigners, I suppose. You're very tired. Hey, press the button and the taxi will come and take you home. How perfect is that? You don't have to worry about the thing. Just, off you go. So this is a really weird one. Okay, so you're looking for a friend, a special friend or whatever. What if your mobile told you and you were close to a good one? Saying, yeah, okay, it's opposite side of the street and you can start the conversations, with your mobile and go on from there. Nah, I'm getting too old for this, I think. But, that's all geographical, tied to the location. Social networks like Foursquare, they do really weird things with this. They have games going on right now where you highlight a place and then you can become a king of that place. So you go and travel, somebody's a king of that place. When the king arrives, everybody gets a little tweet on their mobile device and say, hey, king just arrived, king gets a free beer. And then they've done a version there where you can make somebody a false king. And then the guy comes in, excited because he's going to get a free beer, and everybody laughs at him, and he doesn't. So, go figure. It's sort of youngsters things, these, I suppose. But it's all working with the geographical and location and geospatial. Tag what? So another one lets you tag information. Do it that way. What's this one? This one was. Piccadilly Circus. So basically, this is a great one. So you have your GPS device telling you where the nearest tube stations are, and then you can also look at where the tubes actually go. So you can pull the tube map into it, and then when you're close enough to the actual station, it changes to augmented reality, and now it's actually showing you where you go into the tube station. That's pretty cool. You use it for construction management, 3D industry training, the typical kind of things that you've seen. This is a great one. So we need one of these in New Zealand as well. Spot crime. So you can put in and you just saw somebody steal somebody's bag. You put it into the device and say, hey, I just spotted some crime, and then some other bugger there, tourist for example, comes in and says, show me all the crime in the last hour, and it shows it everywhere, and they go, oh, far out, this is not the right place to be. This is a good one too, car finder. So you have a big car park, your wife parked your car, you have no idea where your car is, so this one actually tells you. That's where it is. Crowdsourcing, this is a good one too. So you want to know where your kids, your old folks are. So it tells you, that your old dad who's getting a bit senile doesn't know where he is anymore. Well, we can find him. We can actually see where he was, what he's been doing. So this one's been just going around in circles. So that's all right. And then you can track criminals or maybe teenagers. It works like this, you just put it on your ankle kind of thing and they can't get it off. I thought that was hilarious, that would work well. Okay, and then you have some borderline stuff. So you have your photosynth, which lets you actually go into really close and look at information. So, all the photos, and then you can 3D, you can find it and zoom in. This is a really weird one. So how you have your site counters. You used to have your site counters or websites. These guys, this is their business. They provide you this revolver map. So you go to the website, it actually shows you the point in the map where people are coming to view it. And it's like a 3D globe kind of thing. So that's pretty cool. News. So you can look at where the big news are in the globe and sort of find that. You can see the spike there. That's obviously something horrible happened somewhere. And then Windows 7 has a whole lot of this built in. Finishing this, some really weird ones. This is the orb, 7,400 LCD panels. It's a real globe thing. It's showing a map and things that happen on that. So it's something that somebody's working on. Photosynth we already talked about. Surface, obviously, you've seen that. That's brilliant. And doing things with that. This is a high-res mobile, 1200 by 800 resolution screen. So that's quite exciting for geospatial people. Paper-thin monitors, so they're playing with those now. So the idea is that these can have a mapping system basically built into it, and you can use it kind of instead of paper. Gloves and glasses, obviously. 3D LCDs are already happening now. Virtual computers. I don't know if anything ever came out of this, but it was a cool idea. So you had a little pen which actually gives you the screen, and it gives you an infrared keyboard. So you carry it with you, set it up, and off you go. Great idea. Okay, this is a weird one. So you'd kind of think that this one here is about making sure that you can find where your kids are and keeping them safe and stuff. No, it's not. It's a car navigation system. So you put it on top of your car there. and you tell it, voice recognition, you tell it where you want to go. And it starts telling you, turn left, and it actually has limbs moving. Turn left, turn right. Whoever can, you know, that's pretty cool. Or these are shoes. You want to go jogging, you have no idea this is a new place. Like, let's say we come to Auckland, we don't really know. Want to go and have a run, so you tell these where you want to go. It'll tell you the route, and actually you have a little thingy on your ear when you're running. It tells you now turn left, you know, actually guides you through your jogging exercise. So this one, reverse geocaching. You have family jewels there. How that opens is you set it up to only open in one location. So you can't open it anywhere else except that. So you give it to somebody and say, it's been set up so that when you get home, it'll open there. So that's when you can open it up. So that's called reverse geocaching. Go figure. Ski goggles. So you're coming down the hill, and it says, you know, this works, this is augmented reality. So it actually tells you that don't go left, that's not a good idea. There's a bit of a rave in there, and yeah, must be useful. So, conclusion before I hand to Nishaka. Geospatial is definitely mainstream now. It's mature, it's well supported. What will happen in the next 5 years? Well, come have a look at that. That's hype cycles. It's an interesting place. It shows you the last 3 hype cycles, new technology, what's actually happening. You can see how things change and what happens to them. Basically, what we do know is that people are coming with innovative new ways of using geospatial all the time. And why not? It's great fun. It's geographic. It's very graphical. It's great stuff to do. Tomorrow, there won't be anything where there won't be something geospatial, whether it's a smart device or hardware, software, cloud. Cloud is happening for geospatial systems as well. And it's going to have a talk about the Microsoft Azure and geospatial tomorrow, so that's definitely worth going to look. Maybe it's time you start looking at it if you don't yet. There's a lot of organizations who do this and can help you out on this and get you started. And I'll hand it over to Nishaka now.
Thanks, Mary. That is inspiring. Before I start, I would ask a question. Can you think of any industry where we cannot use geospatial? Just hold on to your thoughts. Okay, my name is Nishaka Ranavira. So I'm the team leader for software development at ESR. I will briefly talk about ESR, what we do, what's unique to ESR, IT systems and technologies that we use to deliver our science. Finally, the strategic direction and where the GIS will fit into the enterprise architecture of ESR. So ESR is one of the 8 Crown Research Institutes in New Zealand and was established in 1992. It's owned by the New Zealand government and reports to 2 shareholding ministers, Minister of Finance and Minister of Research and Research, Science and Technology. It is set up as a limited liability company and runs as a self-sustaining business. So ESR's mission is to protect people and their environment through science. Hence, most of our work is for public good and public benefit. And for the same reason, we are well known for working with bad bugs and bad buggers. So we have about 400 staff across 4 science centers. The science centers are located in Mount Albert, Auckland, Christchurch, Kenepuru in Wellington, and the newest one is the Wallaceville in Wellington. We are a partner organization at INCIBIT, where we do a lot of human biosecurity and chemical forensics.
Great.
What do? We deliver essential scientific services supporting New Zealand government's public health, food safety, criminal justice systems. We do science underpinning security, community security through forensic science. We are the sole provider of independent forensic services to New Zealand police. We manage the New Zealand National DNA Data Bank. We do crime scene investigation, evidence recovery, DNA profiling, DNA matching. We also do blood and breath alcohol testing for driving. So if you've got caught, it's not actually ESR police, but we do the testing on behalf of police. Toxicology, human biosecurity and all. So the forensic services are actually not limited to New Zealand. We have provided our forensic services and the expert systems around forensic services to Royal Thai Police and Malaysian police. We also do science underpinning public health, areas like communicable disease and surveillance, environmental health, food safety, water quality. So ESI is the principal science advisor to Ministry of Health, and we provide scientific services to MidSafe, Pharmac, Customs, Department of Corrections, DHPs, and various other government organizations. We use a range of Microsoft products and tools to deliver these expert systems and the science to the clients. Most of our expert systems are developed using C# or ASP.NET, and we use SQL as the backend database. So we use Visual Studio as a development tool, reporting services, analysis services, integration services. We use MOS as a collaboration tool because we collaborate, we do a lot of collaboration with the other partner organizations, other CRIs. And most interestingly, we use a combination of .NET and ArcGIS to deliver some of the GIS capabilities on some of these surveillance systems. Episerve is one of them. It's a secure web-based application developed in somewhere around 2005. So ESR hosts the National Notifiable Disease Surveillance Database on behalf of the ministry. Basically, it collates notifiable disease information on a real-time or closer to real-time basis from the public health services. And case demographic is one of the key data fields collected within Episerve. Episerve is developed in ASP.NET with some server-side JavaScript and use the SQL as the backend database for transactional and for data warehousing. This is a forms-based application, so we use Microsoft InfoPath forms to capture data. During the last year's swine flu pandemic, we used Episerve as a base and developed another web application called PANDA, stands for Pandemic Minimum Data Set, for Ministry of Health, to help them to plan and resource management on a pandemic situation. So in both Episerve and PANDA, we display geospatial information in form of a map, and these maps are application centric. So as you can see, these maps are hosted in a .NET application, and it's got two background layers, a context layer and a boundary layer. The boundary layer is the medical authority boundaries, for example, the DHBs or public health units or the territorial authorities. So the user can select which boundaries they want to have. And then on top of that, you have a dynamic data access layer. So it is directly talking to the database and pulling the data on a real-time basis to display the geospatial information. Users can select the data that they want to display on the map, and it will bring the data and display it on the data layer. The users can select a region on the map, and then it will display all the cases within that region. And also, if you want to drill down further, you can select a particular case, and you can see all the details of that case. Didimo is another example. Didimo was developed to collect, manage, and report on the Didimo sampling data. Once again, it is similar to Episerve in terms of maps. We got two background layers, and the boundary layer, instead of the medical authorities, we have a rivers and lakes. And once again, you can select the region and display the detail or the sites. A site in site is a location where a sample is collected from, and you can record the GPS coordinates against the site, and then view the site on a map. So this is a close-up view of an unaffected site. So as you see, we have quite a number of applications developed to with the GIS capability, but all of them are developed in a disconnected way, and it's very, very difficult to produce consolidated business intelligence. For example, Episerve holds all the geospatial information for notifiable disease, while Didimo is holding all the geospatial information for Didimo affected lakes and rivers. So ESR wants to be the innovative leading science provider to New Zealand and also to Asia Pacific region. So they have come up with 5 strategic initiatives, and one of them is to deliver intelligent information management systems, and GIS is a major part of that. So what we have done is ESR, in partnership with Geospatial, Matty and his team, developed a geospatial architecture for ESR. And our vision is to protect people and their environment through efficient and effective use of geospatial data and technologies. And we have identified 5 key EA components around this. The first one is the business architecture. So to improve ESR decision making by incorporating location-based approaches and data. So then the data architecture, provide ESR and partners with geospatial data. Then the applications architecture, again to provide ESR and the partners the applications and the web services that they need to analyze and interpret geospatial data. Then the technology, implement an enterprise-wide technical infrastructure to support the applications and the web services. Now, this data application and technology, it's very important not only for ESR, but also all the partner agencies and to the general public. Then the most important thing is the governance. Establish an effective governance structure for setting up the priorities for the geospatial data and the technologies that we use. So finally, once we identified these EA components, we managed to come up with or map them on the current enterprise architecture. So we have got the enterprise spatial services runs parallel to the standardized reporting and the management, and also the data management, and most importantly the consolidated and centralized spatial database, so that you can do more effective business intelligence. So thank you, and I'll hand you back over to Matti.
So as you can see, there's a system that's a strategy on fully enabling geospatial within your enterprise IT, and in ESR's case, it's all .NET except for the mapping engine, which is Esri. Okay, let's skip through that. Right, this is the third part. So we're going to do something slightly different. So I always like bribing people. So I have about 3 4 gig memory sticks there. And what I'm going to do, this is sort of instead of the Q&A, but it is Q&A, but it's slightly different. It's actually we ask you. So what we want to do, first of all, I'm gonna need some help here. So I'm gonna get if we can get Ed coming over. So Ed is the principal program manager for SQL Server Spatial from Seattle, and Jay is Eagle's Esri evangelist, aren't you? Something like that.